hard disk number 1, number 2, number 3, number 4 to form one RAID. Okay, so this is basically your RAID LAN. Then you will use this LAN to mount to your server as a hard disk, okay, as a virtual disk. So your server is going to see this capacity over here. Then you select another 4 more disks. Okay, for example, another 4 more disks over here. Okay, these 4 disks, you make it into a RAID 3. Okay, you make it into RAID 3. So in this case, this LAN will become RAID 3 and you mount it to your server. So your server only will see one hard disk over here. So basically, you virtualize this 4 disks itself. Okay, so basically that is the traditional RAID. You have to RAID the physical hard disk itself. Okay, hard disk number 1, number 2, number 3, number 4. Okay, then after that, you need to mention which disk will be a hot spare disk. Okay, over here. So you have a special disk here will be a hot spare disk. And you need to plan it manually yourself. You have to plan it manually yourself. So you have to say, okay, this number 1, 2, 3, 4 become RAID 5. 6, 7, 8, 4, 5, 6, 7, 8 become RAID 3. Then number 9, you become a hot spare. Okay. So what is a hot spare? So hot spare basically is a backup. Okay. So when will this backup be used? Any of these 8 disks on the 8 disks that you construct the RAID, there's a hard disk failure. This hot spare will immediately take over. If you fail, let's say that these 3 fail, right? This number 3 fail over here. So in this case, this disk actually will join into these 3. So he will basically join into it. Okay? So you will basically join into this 3. And you will replace him. So after you replace him, then you can do the RAID reconstruction, okay, on the part here. But the bad thing is that you need to manually plan the hot spare itself. So you have to say, okay, number 9, this is a hot spare. So if you don't plan any hot spare, you will not have any hot spare. So that means that when there's a disk failure, he will just run in something, we call it as a degrading mode. Okay, you will run in degrading mode. So basically, your read and write will be very slow, right, when you are in a degrading mode. So in order for you to get up from a degrading mode, they need to redo the reconstruction. So how does it do the reconstruction? You have a hot spare to replace the broken disk. You will reconstruct on the hot spare disk itself. Okay? So that is how the traditional work. Okay? Everything is physical hard disk. Okay, then we move into the LAN virtualization. So what's the difference between traditional RAID and LAN virtualization? Okay, so if you look into here, okay, it's almost the same concept. I select this number 1 to number 4, let's say that to form a RAID 5 again. Okay, RAID 5 again. Okay, for this guy, form a RAID 5 again. Okay, after that, another disk. Okay, another disk. Okay, another 4 more disks. Okay, this one, I form the RAID 3. Let's say RAID 3 in here. Okay, I form 2 RAID. So basically, this is almost the same like your traditional RAID, right? You get the hard disk, you form it into a RAID group. Okay, now the only difference is that in the traditional RAID, once you form this RAID LAN over here, this guy over here, this RAID LAN, you immediately mount it to your server. So your server will use it immediately. But your server will only have RAID 5 protection. That's all. Okay? Only RAID 5 protection. The same thing happening on this disk. When you mount it to your server, your data is only protected by RAID 3. You get only one RAID protection only. Okay? So the difference between traditional RAID and LAN virtualization is that in traditional RAID, when the RAID LAN is constructed, you mount it. But in LAN virtualization, once the RAID LAN is constructed, you don't immediately mount it. So what you do, you basically put all the data in the RAID, all the space in the RAID 3 and RAID 5, you combine together and form a storage pool in here. Okay, storage pool. You form a storage pool in here. Okay, so this is basically a storage pool. So in the storage pool, basically they will cut this RAID 5 into a smaller pieces, okay, and RAID 3 into a smaller pieces. So you have a piece here will be a RAID 5, okay, R5. Okay, so let's say that this piece is a RAID 5, this piece is a RAID 3, okay, RAID 5, and RAID 3. That's it. Okay, you have a lot of pieces like this. So all of these pieces will be separated in a storage pool itself. Okay, so this storage pool basically will form a total size. So if let's say that this RAID 5 give you, let's say it give you 5 terabyte. Okay, 5 terabyte of size in the RAID 5. Then we'll go to RAID 3. Let's say the RAID 3 give you 3 terabyte. Okay, let's say give 3 terabyte. So in this case, your storage pool will be combined 5 and 3 terabyte together. So your storage pool size will be basically equals to 8 terabyte. Okay, so this is basically the storage pool size. So inside is combination of RAID 5 and RAID 3. Then after that, this is where you create your LUN. Okay, we call it LUN. Okay, logical unit number. So this LUN, where do you get the size from? You get from the storage pool. So the storage pool tell is 8 terabyte. Let's say that my LUN, I need to have 1 terabyte. Okay, but the question is, this 1 terabyte, you come from RAID 5 or you come from RAID 3? Okay, the answer is you will get a piece from both. How many percent? You do not know. But this LUN here, you will have RAID 5 protection, you will have RAID 3 protection. So some data might be written in RAID 5. Some data is written in RAID 3. Okay, so that is basically how this 1 TB will be formed, because it's from the storage pool itself. So this is basically what we call it as a LUN virtualization. Okay, then after that, okay, you also need to plan your own hot spare disk, because you see that there's no hot spare over here. So that means that physically, let's say that I have a physical hard disk. So you still have to manually mention this number 9 is a hot spare, this number 10 is a hot spare. Okay, so you still need to do the hot spare planning on the LUN virtualization. Okay, yes, yeah, you have any questions?
Yes, right.
Mm-hmm.
Actually, I didn't understand this LUN virtualization well.
You didn't understand LUN virtualization?
Yes, is how it is. Can you repeat this? This only LUN virtualization.
Okay, as I mentioned before, in LUN virtualization, you still select which hard disk to form 2 RAID. It's the same as traditional RAID, am I right? It's the same thing. Okay, you select 1, 2, 3, 4, form a RAID 5. 5, 6, 7, 8, form a RAID 3. You get the same result as your traditional RAID. The only difference is that in traditional RAID, you will immediately use this and mount to your server. And you immediately use this RAID 3 to mount to your server. In LUN virtualization, after you construct these 2 RAID LUN, you mix them together into a storage pool. So you cut that into a smaller pieces from the RAID 5 and the RAID 3. You form a storage pool over here. Okay, so this storage pool, you'll see a pieces will be RAID 5, a pieces will be RAID 3 over here. RAID 3 right. So this storage pool will be the one that you form your LUN, that you're going to mount to your server. So this LUN here, let's say that I want to get 1 terabyte. But this 1 terabyte, will it come from RAID 5 or will it come from RAID 3? The answer is, you will come from both. So some of these might be coming from RAID 3, some of these will be coming from RAID 5. So that means that when you store the data into this LUN, there are some data it will be protected in RAID 3, some data will be protected in RAID 5. And your data will be distributed to all 8 of the disks over here. It will be distributed. Okay? But you will store on which disk, you will never know because it's virtualized already. Okay? So that's LUN virtualization. Okay, is that explained to you, Sanya?
Yes.
Yeah, good. Okay, so the same thing, hot spare in the LUN virtualization, you still need to plan it manually yourself. Okay, you still need to plan it manually yourself. So that means that there's 8 disks over here, this number 9, this number 10. You still need to mention this number 9 and number 10 is a hot spare. If you don't mention this one, you will not have any hot spare. Okay, so this is LUN virtualization. Okay, then we go into RAID 2.0 plus. So what's the difference between LUN virtualization and RAID 2.0 plus? Okay, so the difference between LUN virtualization and RAID 2.0 plus is that, first of all, all these disks must be the same disk. If it's a SAS, it must be a SAS. If it's an SSD, it must be SSD. Okay, and in this case, okay, all these RAID will become from SAS disk, all these RAID will become SSD disk. But in RAID 2.0, you can see that the first level, you already done a virtualization. Okay, you've done the virtualization already. Okay, so all these guy will be virtualized into something we call it as a chunk form. Okay, you cut them into a smaller pieces. We call it as a chunk, okay, from your hard disk itself. Okay, then this chunk you will put it into a. Okay, we call this as a. Okay, we call this as a. Where's my text? Okay, we call this as a disk domain. Okay, we call this as a disk domain. So you cut all your hard disk into a smaller pieces, you put it into a disk domain. So all your disk domain, you will have a multiple type of disk inside there. You will have some piece of SAS, some piece of SSD, some piece of nearline SAS. Okay, then from there, you will form the LUN. So you will form your SAS, what rate you want from the SAS, what rate you want from the nearline SAS, what rate you want from the SSD. So in the rate formation, they still need to follow the same type. So if it's SSD, form all SSD in one rate. If it's a SAS, form all SAS in one rate. If it's a nearline SAS, form all nearline SAS in one rate. Okay, so basically this is what we call it as basically is form a rate group. So this is your rate. Okay, so this, let's say this is a rate 5. Okay, this is a rate 3. Okay, you form this one. Okay, then after you form a rate 3 and rate 5 and rate 3, you don't immediately mount to server. Actually, the graph here has something wrong. So you shouldn't be immediately mount to the server. From here, they will perform the LUN virtualization like this one. So these two rates, basically they'll form another storage pool. Okay, so on top of the disk domain, you have another thing, we call it as a storage pool. Okay, so in here you'll form a storage pool over here. Okay, you form a storage pool. Okay, you form a storage pool. Then this storage pool will get a little bit from rate 5, a little bit from rate 3. Everything will mix into a big storage pool. Then from the storage pool, you create the LUN. Okay, from here, you create the LUN itself. So you create the LUN over here. Okay, so your LUN will get a little bit from rate 5, will get a little bit from rate 3. And if let's say that your rate 5 is a SSD, your LUN here will get a little bit SSD over here. If rate 3 is a nearline SAS, your LUN will get a little bit of nearline SAS space. Okay? So basically that is how it works. So you have to go through few layers. So from the disk domain, go to a storage pool, then only you can create a LUN. When LUN virtualization from the hard disk straight away to rate to storage pool, then you get your LUN over here. So you do not have this layer over here in the LUN virtualization, the disk domain area. Okay, so that is basically the difference between LUN virtualization and RAID 2.0. Okay, one more thing that's very important comparing LUN virtualization and RAID 2.0 is that you no need to say that, okay, this disk is a hot spec. Okay, you don't need to plan, this disk is a hot spec, this disk is a hot spec. You don't need to do that. Okay, compared to LUN virtualization, you still need to mention that physical disk number one to become a hot spec. RAID 2.0, you need to mention which disk is a hot spec. Then in this case, where is the hot spec? The hot spec will be distributed among all the disks. It will be distributed. So you no need to mention disk number 9 is a hot spec. Okay, they don't have. So they do not have a dedicated disk to become a hot spec. All the disks will have a little space to form the hot spec space itself. Okay, so that's how they form the hot spec in RAID 2.0. Yes, Augustine, what question do you have?
Concerning the the size of the disks in the pool, in your RAD 2.0, the size of the disks in the RAD 2.0. The last class, you made us understand that zero, 1, and going down. So now that they are all, like in this other example you give us in virtualization, and we can see that the blue disks were given 5 terabytes and 3 disks, and the other yellow disks were given 3 terabytes. That's to form the RAD 5 and RAD 3. So obviously they are not of the same size, but they were able to all go into the pool of a total of 6 terabytes. Now, in the RAD 2.0 now, can you have multiple disks of different sizes? And how do they then match? How do they then match?
Over here.
Okay.
This thing over here, this layer, top layer, not the bottom layer. This top layer over here is actually the same thing as LUN virtualization. The only thing different is that you don't get this, you don't construct this RAID directly from the hard disk. You see that? This one is constructed directly from the hard disk. This one, you create a disk domain first, then only you create the RAID. That is the difference.
Yeah, that's what I'm saying. Now, the disks that are now used in the pool there, are they going to be of different sizes? And is there a mechanism to determine how they are going to be selected for them to merge into forming the RAD type?
I don't understand the question.
You see, in the RAD 2.0 now, there is a pool already of hard disks.
This one? You mean this one?
Yeah. Yes, down there, yes. There's a pool of hard disks in there.
Yep.
And in there, the sizes, from what you are saying now, is that there are different sizes. Yes. Now,
You mean the hard disk can be different size?
Yes, yes. Or does it be the same size?
Can it be different size? I believe there shouldn't be any issue because you virtualize it into a chunk form already. Yeah, so it can be a different size here. Doesn't matter.
Okay, when they go into the pool, they are already virtualized before they form the RAD. They already virtualized before they form the RAD. Okay, then it can work. Okay.
Yeah, so basically this one, all this must be same size. All this must be same size. But in here, okay, it can be different size. You still can virtualize it into a pool because when you virtualize it, you become a capacity. I don't see your hard disk anymore. So basically, it's just one big pool of capacity. So you get from the capacity itself. So it doesn't matter which disk is different size than your disk. You still can construct into RAID 2.0. Okay?
Okay, I get it. Thank you.
Yep. Okay, so basically that is the concept of RAID 2.0 plus. Okay, basically you will see that you virtualize two layers. One layer on the disk, another layer on the RAID. So you are going two layers. Okay, so that's what we call as RAID 2.0. So the benefit of RAID 2.0 is that your hot space is distributed among all the disks. You do not need to plan which disk is hot space. Okay, that will help you to automatically distribute it among all the disks that you join into the same disk domain. Okay, so this one will be the RAID 2.0 plus technology. Okay, so let me just clear the drawing. Okay, so there's some terms, okay, that you need to know, okay, when you are talking about RAID 2.0. Okay, so you have this domain, okay, that we mentioned just now. So that's where you select which hard disk to put into the domain to be virtualized. Okay, so that's why I call it disk domain. Then you have the storage pool. After you create the disk domain, get the virtualization first layer, then they need to virtualize another layer on the storage pool. So that's where you form your RAID. Okay, that's where you form your RAID and virtualize it. So that is the second layer. Then after that, you will form the volume. Okay, you form the volume. Volume basically is equal to LUN actually. And volume and LUN are the same thing. Just that in storage, we call it volume. For host user, for server, we call it LUN. You mount the LUN, you don't mount the volume. Okay, so basically they are referring to the same thing. So volume is the one, okay, that going to construct it into a LUN. Okay? Okay, so these are some of the terms you need to know. Then after that, there's some name over here. Okay, LD. What does LD stand for? So LD stands for logical drive. Okay, this is basically called logical drive. So logical drive means your physical hard disk itself. Okay, if you put in one SSD, storage, you just consider that SSD as a logical drive number one, SSD. Okay, so if you put in a SAS, okay, you put in a SAS, then this logical drive will be a SAS logical drive. Nearline SAS logical drive. Okay, then after that, this logical drive, when you go into the disk domain, they need to virtualize it. Basically, if it's 1 terabyte, they need to cut it into a smaller pieces, then virtualize it. So the layer is what we call, the pieces that we cut up is called the chunk. Okay, this is the guy, CK. Okay, we call it as a chunk. Okay, so this is basically after you put in the disk into the disk domain, I need to cut the 1 terabyte into a small chunk pieces and put it into the disk domain pool. Okay, into the disk domain pool. Okay, then after that, when you want to form the extend, so extend is basically the one that you form to create your RAID. Okay, the one that you create your RAID, they will form using the extend. So the extend comes from where? First of all, you have a lot of chunk. Means that if you, let's say that you have a lot of SSD, means that when they divide it, you will see a lot of chunk over there. So in this case, to get every pieces on each and every one of the disks, they need to form a chunk group. They group them together. Okay, they group them together. So some of this chunk might come from SSD number 1. Some of this chunk might come from SSD number 2. Some of this chunk might come from SSD number 3. So they form it as a group. When they form it as a group, they cut it horizontally. Okay, you form it as a parallel, they will cut it horizontally. So that when you cut it, it will become an extend. So this extend will be the one that to form your RAID. Okay, to form your RAID, the whole stripe itself. Okay, that is basically come from extend. Okay, the stripe itself. So they come from multiple hard disks. They form the extend itself. Okay, so this is the one that form your RAID. Then after that, you form your extend. then you form your LUN. Okay, you form your LUN. So from the extent, you form the LUN itself. Okay, so there's some name that you need to know. So this is a LUN. So grain is a smaller block come out from extent. So after you cut from the extent, you cut it even smaller to form the grain. Okay, to form a grain. Okay, so there is a smaller form of extent only. So this is the type of LUN we are talking about. So in the LUN, you have two types of LUN. Okay, type of LUN. So you have the thick LUN and the thin LUN. These two. So when you have these two types of LUN, basically they will form from different elements. So the thick LUN will be coming in from extent. The thin LUN will be coming in from the grain. So it's the smaller version of the extent itself. So it cut from the extent one. So the grain is to form thin LUN one. Okay, so that's why you have these two types of volume over here. So this is to form your thick. This is to form the thin. Okay, so what is the thin LUN? What is the thick LUN? I will explain it later. Okay, so right now you just need to know extent is to form thick LUN, grain is to form thin LUN. That's enough. Okay, that's enough. So this is some terminology or logical object you need to know when we talk about rate 2.0. Okay. Okay, then we look into the basic principle of rate 2.0. Okay, so if you look onto this here, okay, if you look on here, it's quite confusing. So let me just draw it up, okay, for everyone. Okay, everyone can see my whiteboard. Huh? Okay, so first of all, okay, when you want to form rate 2.0, you need to purchase the hard disk first. Okay, those are what we call it as logical drive. Okay, logical drive. So let's say that right now I purchase a lot of hard disks. Okay, let's say that right now I have a lot of hard disks. Okay, just let me draw them. Number 1, number 2, number 3, number 4, number 5, number 6, 7, 8, 9, and 10. Okay, so let's say that I have 10 of them. Okay, let me rename them. 1, okay, 2, 3, 4, 5, 6, 7, 8, 9. So I have 11 of them. Okay, doesn't matter. Okay, so I have 11 of them. Okay, right now I have 11 hard disks over here. Okay. Okay, so let's say that this one, okay, this one to this 4, okay, this 4 disks, okay, from this one to this 4 disks is basically, okay, this 4 disks is, let's say that is an SSD, right, SSD. Okay, then this 5 to this 6, this 5 to this 8, okay, let's say that this 3 disks is SAS. Okay, it's a SAS disk. Let me add one more disk. Okay, up to number 12. So let's say that I add one more disk, number 12 disk. Okay, so let's say that this 9, okay, this 9 to this 12, this is basically a nearline SAS. Okay, NL SAS disk. So I have 3 types of disks in my storage. Okay, so these 3 disks, okay, this SSD, SAS, and nearline SAS, let's say that SSD size is different from SAS, SAS drive is different from SSD, nearline SAS, okay, it doesn't matter. So I have 12 of these disks, okay, 4 is SSD, 4 is SAS, 4 is nearline SAS, okay. So first thing you need to do is that all these things is what we call as logical drive, LD. So you need to select which disk to put it into the disk domain. Okay, you need to create a disk domain first. So basically, you need to select which disk you want to put into the disk domain. So first of all, you can select SSD only, or you can select SSD SAS, or you can select everyone. That's a choice of you, which one you want to select. So let's say that I want to select everyone. Okay, I want to select SSD. Then they will ask you, SSD have 4 disks. How many you want? Okay, how many you want? So let's say that I want to put in 4 disks, all of them. Okay. Also put in 4 of them. Okay, and nearline SAS I also put in 4 of them. So actually I put in everything. You can put in everything or you can put in only certain. I only want to put in 2 nearline stars. Okay? You also can do that. Okay, the reason why I put the number 4 is that, okay, if you remember, I still mentioned, in order for your storage system to work, you need to have 4 hard disks. So that means that every type you must have 4. Then only it will work. Okay, so that's why I need to have 12 minimum over here. If let's say that I want to make it into 3 different type of hard disks in here. So 4 over here. Then you put all these things into this domain. Okay, this domain. Okay, so from here, he will make your 4 hard disks into a chunk form. They'll virtualize it into a chunk form. So first of all, I need to know what is the size of one SSD. So let's say that one SSD is equals to, let's say, 1 terabyte. One SAS is equals to 2 terabyte. That's it. Okay, NL SAS is equals to 3 terabyte. Okay, let's say, okay, this is basically the size of your hard disk. So one SSD is 1 terabyte. So 4 of them, you will get 4 terabyte. But out of this 4 terabyte, okay, they might minus something out, because when you create a disk domain, you put in the disk into the disk domain, they will ask you one more thing. What do you want to put in for this guy, the spare? Okay. So in hot spare policy, there's 3 choices for you to do. You can either select none, means that you don't want hot spare on SSD, as low, or hot spare policy. So this is the 3 choices you can put: none, low, or high. Okay, none, low, or high. These are 3 policies you can choose over here. So let's say that I want to select, because it's an SSD, it's important, maybe I want to select high. So if you select high, how many space out of these 4 disks you will take? Okay, so from every disk is 1 terabyte, right? So 1 out of the 4 terabyte, how many space you will reserve for hot spare? So in this case, you cannot decide because it's determined by this policy. So if you want to know the exact number, if you want to know the size, the disk size that is going to consume, right? Later I will show you when we do the configuration. You will see when you go into the hot spare policy, they will show you a table over there. If you put in how many number of disks over here, if you select high, how many disk size you will take out from here. And which disk you will take out? You will take out distributed. All 4 disks, they will take a little bit from the 4 disks over here. So it will not be one single disk to become hot spare. Okay? It will be distributed. But you just need to select the policy only. High, low, or none. Okay, in here. Okay? So let's say that I put in high. Okay? Then after that, below here, this guy, my hot spare, I put in, okay, so each and every one of the hard disks, you have to select their hot spare policy because you are different type. Okay, so this one is select high, you can this one select low. Okay, you can say SAS select low, no problem. Okay, then after that, your nearline SAS, okay, maybe it's not important, you say none. You don't want to put in the hot spare at all. So you can select like this. Okay, different type of this, you can select different type of hot spare. But the same type of this only govern one hot spare policy because they need to distribute the hot spare among all the 4 disks itself. Okay, so this is what happened over here. Okay, so let's say that before you minus the hot spare, okay, before you minus the hot spare, the size is 4 terabyte. Then after that, you select hot spare policy high, maybe it's minus 1 terabyte out. So you will be balanced with 3 terabyte. So the 1 terabyte you cannot use because it's already reserved. Okay, in nearline SAS, let's say that this is 2 terabyte. I have 4 of them. I have 8 terabyte. Okay, then I minus out because the hot spare policy is low. So let's say that I minus out also 1 disk space or half disk space. Okay, so in this case, let's say that I minus out also 2 terabyte out of it. So basically, you will balance 6 terabyte. Okay, 6 terabyte. So in this case, nearline SAS, your policy is done. So when you have 4 disks, you have 12 terabyte. Okay, so basically it's 12 terabyte. So you do not have hot spare, 0 terabyte. So I don't reserve anything. So your size will still remain as a 12 terabyte. So basically the total here, what do you get? Okay, the total here, what do you get? So 3 terabyte for SSD, 6 terabyte for SAS, 12 terabyte for nearline SAS. So this is what you will get after you minus the hot spare. Okay, so this is the first level virtualization. virtualize it, then they'll take out the hot spare. So in this form over here, actually, this is basically a chunk already. Okay, a chunk, C-H-U-N-C-K. C-H-U-N, this is chunk, yeah. Okay, I believe it's called chunk, let's see it. Okay, C-H-U-N-K, correct. So all these things is a chunk. So what is your chunk size? So your chunk size is equals to actually 64 megabyte. Okay, that is the chunk size. Then you might be saying, this is a 3 terabyte. How can it become a chunk? So basically, you just use 3 terabyte divided by 64 megabyte. Then you will know how many chunks you will form. Okay, how many chunks you will form. So this is basically the basic unit to after you virtualize it. So they will cut all these 4 disks into a chunk from 64 megabyte, 64 megabyte, 64 megabyte, until you will get 3 terabyte. So this 3 terabyte will be forming a lot of 64 megabyte below that. The same thing happening on SAS and nearline SAS. Everyone are the same. They will cut it into a chunk form. Okay, 64 megabyte. Okay, so all these things will be going into the disk domain pool itself. A lot of 64 megabyte coming in from SAS, nearline SAS, and SSD. So the more terabyte you have is that the more pieces of chunk you will have into the disk domain. Okay, so this is the first layer of virtualization. Okay, so up to here, anyone have any questions or not? Before we proceed to the next virtualization layer.
Hello.
Yeah, who is this?
Hello.
Olaji?
Good afternoon.
Yeah, afternoon.
Please, the word chunk, can we catch it? Do you mean catch it? Or what do you mean by chunk? It's got to 64 MB. I want to get clarification.
Chunk is the smallest size you can read on the you can write on the hard disk. That is the smallest size you can write on the hard disk. That is called chunk. So that's why the hard disk need to be separated into a chunk from. That is basically the smallest unit you can write into the hard disk. You cannot be anything smaller than 64 megabyte. Okay, so that is a chunk. You can actually imagine a chunk is like the sector. If you still remember the hard disk property itself, you have a sector. That is actually almost equivalent to chunk. It's 64 megabyte. So when you write your read-write head right into the disk, it's writing 64 megabyte into the disk. That is the whole chunk itself. Okay, that is what we call as a chunk here. Okay, Bolaji? That is the smallest unit you can write onto the hard disk. So that's why they need to separate into something called chunk. Okay?
Yeah, thank you. The smallest unit you can write on the hard disk is chunk. That means 64 MB by size.
Yep, correct.
Read write. Okay, thank you very much.
Okay. Anyone have any other questions? Yes, David?
Yeah, yes, I do. May I just take you back to the hot spare?
This one?
Initially, I thought the hot spare was like a complete disk that is put, that is set aside to replace in an event where we have a challenge. But I think you explained something else when you're talking about the hot spare here.
Okay, RAID 2.0, because in RAID 2.0, you do not have a dedicated disk to become a hot spare. Your hot spare is distributed.
Okay.
That is the reason why you don't mention the number here, because you will not know. There's a 12 disk over here, right? You can see there's 12 disks over here. So where's your hot spare disk? You do not have a hot spare disk because it's distributed among all the 12 disks. Okay, how is it distributed? Okay, the first 4 disks here is high, so this 1 terabyte will be coming in from these 4 disks. The second, this 5 to number 8 is a SAS, so it's a 2 terabyte. It will distribute full 2 terabyte from here. Nearline SAS, you say none, so there's no hot spare in here.
Okay. All right. No, the fact that you're saying that's distributed, I think that clears the air. Because I had the physical device in mind, as opposed to...
In RAID 2.0, you no longer have physical disk to become a hotspot. It's distributed.
Okay. Thank you.
You're welcome. Okay, anyone have any questions before we proceed to the next virtualization? Yeah.
It's Roy.
Yeah.
How do you calculate the usable capacity?
Pardon? How do you calculate?
How do you calculate the usable capacity of
you
that
need to calculate. When you configure, it will tell you how many is balanced. After you create this hot spare policy, you don't need to do this calculation one, because when in the system, after you put in the hot spare, it will minus out the hot spare and tell you how many is usable. This is just for me to show you guys clearly on the calculation part only. Actual calculation, you will leave up to the system to do it. After you put in this domain, after you select the hostware policy, he will minus out the space and tell you how many is usable. This one you don't need to do calculation.
Thank you.
Okay. Yeah. Any other one have any questions? Okay. No questions, huh? So if no question, then we go into the second level of virtualization. So right now you have a pool, you have this domain of pool of a lot of chunk over here, 64 megabit of chunk. Okay. Okay, the next thing you need to do is to form a storage pool. Okay, to form a storage pool. Okay, so this is the second level of virtualization. Okay, to form a storage pool. Okay, to form a storage pool, the same thing they will ask you as this domain. They will ask you what type of disk you want to put it into this storage pool. So you can put in only SSD, or you can put in SAS, or you can put in all of them. Depend on you. Okay, what type of disk you want to put into the storage pool. Okay, so let's say that I want to put in all of this type of disk. So I'll put in SSD. Okay, SSD. Okay, I want to put in SSD. So when you put in SSD, the first thing he will ask you, okay, right now you select SSD, what rate you want to configure, what type of rate policy you want to configure. So that's all those rate, traditional rate that we talked about yesterday. Rate 0, rate 1, rate 3, rate 5. Okay, so this is the first question they will ask you. How many rate you want to configure? So let's say that SSD, I want to configure it as a rate 3. Okay? I want to use it as a rate 3. Okay, then after that, rate 3, you have a lot of type of rate 3. There is a 2 disk plus 1P, 2 disk plus 1P, so basically 1 parity, or you can change this into 3 disk plus 1P, 4 disk plus 1P. Okay, how many you want to create? Okay, so let's say that I want to make it into a 2 disk plus 1P. The format of the RAID 3 I'm going to construct is 3 disk, 2 disk plus 1 parity disk. Okay? Okay, then he will ask you, okay, so in this case, your SSD, you have 3 terabyte of free space from the chunk here, 3 terabyte. So out of the 3 terabyte, how many you want to be created? How many you want to create? Right? How many you want to create? So let's say that out of the 3 terabyte, I only want to use 2 terabyte. Okay? I only want to use the 2 terabyte. Oh, okay, simpler. I use everything 3 terabyte because the calculation is simple in this way. Right? I want to use 3 terabyte in this case. Okay, so this 3 terabyte will use to form a 3 disk, 2 disk plus 1 parity. Okay, so in this case, out of the 3 terabyte, I need to minus out the parity. Okay, this is the total size, right? 3 terabyte. Okay, so this is the size, 3 terabyte I want to use. Okay, then after that, I need to minus the parity, which is a 1 disk. Okay, so let's say that is 1 terabyte. Then you will see that after you construct the SSD, you only will see 2 terabyte balance because this 1 terabyte will be coming from the parity. So this is basically the parity size itself. Let's say your parity is 1 terabyte. Okay, normally it's not that big. Yeah, so I just make it into simple form. 3 terabyte to form these 3 disks minus 1 terabyte of parity. So you are left with 2 terabyte of usable space. That is your usable space after you minus the parity. Okay? Okay, so the same thing happening if let's say you want to select SAS. Okay, you want to select the SAS, then they'll ask you, okay, in SAS, what type of rate you want to run? So you can run a different rate. I want to run a rate 5 on this guy. Okay, run a rate 5 on this guy. Same thing, 2 disk plus 1 parity. Let's say. So I need to form 3 virtual disks, 3 virtual rate disks itself. And how many I have? I have 6 terabyte on here. Okay, I have 6 terabyte on here. So let's say that the same thing. Okay, I use 3 terabyte to form the RAID 5. Okay, then I need to minus out the parity. Let's say the parity is also 1 terabyte. So you will see balance 2 terabyte. So this is basically your usable space on the SAS itself. Okay? Okay, then the last one, I want to form the NL. Okay, let me just put it short form, nearline SAS. So let's say the nearline SAS, I want to run it as RAID 6. Okay, I want to run RAID 6 for this guy. Okay, because I'll protect more data on here. So RAID 6, okay, minimum you need to form is 2 disks. So I form 2 disks plus 2 parity. Okay, do this from 2 parity. So out of the RAID 6, there's a 12 terabyte to construct these 4 disks. Okay, 12 terabyte to construct these 4 disks. So how many you want from this 12 terabyte? So let's say that I'm gonna use, let's say, how do I divide it? Okay, let's say I'm gonna use 8 terabyte. Okay, 8 terabyte. So let's say that one parity is 1 parity here is 1 terabyte. So I minus out 2 terabyte. Okay, minus out 2 terabyte. So basically, let's say that I get around 6 terabyte. Okay, from the parity itself. Okay, so this is basically your usable space in here. Okay, this is your usable space in here. So how do you form this storage pool? Okay, how do you form this storage pool? So in this domain, we call it as a chunk. Okay, to form the RAID, okay, to form the RAID, first thing they need to do, they need to form a chunk group. Okay, they need to form a chunk group. So basically, they will group a 64 megabyte together. So basically, it's like this. Okay, so let's say that one bar here is 64 megabyte. I will form a lot of 64 megabyte bar like this. Okay, 64 megabyte, 64 megabyte, 64 megabyte, 64 megabyte, like this. Okay, let's say this is the chunk group. So this is all your chunk. So one of this is one chunk. So I form a group, I group them together. So this chunk come from which hard disk, you will never know because it's virtualized already. Okay? It's virtualized already. So you never know come from which hard disk. So you can just assume maybe this one come from this number 1. Okay, let's say that this come from this number 1, this come from this number 1, number 2, number 3, number 4. Okay, so you have these 4 disks over here, 1, 2, 3, 4. So it comes from a distributed manner. Okay, so in order to form a RAID, then they will cut your chunk group vertically like this. Okay, they will cut it like this. Okay, they cut it like this. So this thing is what we call it as a extend. Okay, extend. So what is your extend size? Okay, so what is extend size? So your extend size, okay, so extend size is basically equals to 4 megabyte by default. Okay, 4 megabyte default, but you can change it. Okay, basically you can flexible adjust the length, okay, the size of your chunk itself. So by default it's 4 megabyte. You can change it from minimum 6. Basically minimum is, let's see, minimum is, kind of forget, 512. Okay, 512 kilobyte. This is the minimum you can go up to 64 megabyte. Okay, up to 64 megabyte. So basically, the size of the extend you can change. Okay, you can change the size of the extend itself. Let's see. Okay, there you go. So this size over here, this length over here, this length, okay, this length over here is what we call it as an extend size. So it will cut from multiple chunks. So you see that chunk, some chunk is come from this number 1, some chunk is come from this number 2, some chunk is come from this number 3, some chunk is come from this number 4. So when you write the data, you will write it parallelly. So you write this one, this 2, this 3, this 4. You write it like this. So you can see that your data will be distributed among all the hard disks. So that is how they form the RAID. Okay? That's how they form the RAID. So basically the extend is the one that's going to form the RAID bar itself. Okay, that's how they form this guy here. Okay, the 2 terabyte, 6 terabyte. So they'll come from the 4 megabyte, they'll form until 2 terabyte of extend. So you cut it a lot of pieces. Okay, of 4 megabyte from the 2 terabyte here. So they'll cut a lot of them. Okay, so they'll cut like this. Okay, cut another 4 megabyte, cut another 4 megabyte, cut another 4 megabyte. Okay, so they'll form a lot of extend over here. So all these extend are going to store into your storage pool. Okay, are going to store into your storage pool. So your storage pool, you will have a lot of extend coming in from SSD. Some come from SAS, some come from nearline SAS. Okay, so basically that is the second level of virtualization. After you form the first disk domain, I do the storage pool one more time. Okay, so this is the second level of virtualization. Okay, so this is basically what formed the storage pool. Okay, so up to here, anyone have any questions or not on the second level? Yes, Bolaji?
Yes, thank you. My last question was need to know the chunk, the chunk, which was 64 megabyte, and you told me that chunk is the read and write ability over on the storage. Then we go to the second level, which is a storage pool. Now I can see that you sliced the chunk group. What's the purpose of slicing them? Well, I can see that you said the minimum of the slice could be from 4, this extent, you said extent 4 megabyte to 64 megabyte.
No, 5112 KB.
Before yes, 512 KB. Yeah, before it was sliced, it was virtualized. It was virtualized, right? We could not define the sizes. So I need to know why we now have the slice. Why is this slice? So
because you already virtualized
SSD RAID 3. Okay, virtualized. Okay. So and we must define the chunk size on the SSD RAID 3.
This one
right?
you cannot define.
We can't define
64.
Oh yes. Okay, that's in block, right? Block size. Okay, now, so when we come to the storage pool, in the virtualization, the chunk group, we need to slice it so that we could get the defined chunk size on SSD RAID 3, right? Okay.
Yep, correct.
Okay. Thank you very much.
So that's why this is a 2-level virtualization. You virtualize first level, then you virtualize second level. Yeah, David, just now you have questions?
Okay. I think my question was related to what my colleague was just actually talking about. I wanted to find out exactly the link between the chunk itself, because I was thinking that a chunk group would simply be a group of chunks. But now this explanation that you've given here is somehow, I think in my mind, bringing a little bit of some confusion. But I'm sure I'll catch it up later on. I think we can proceed.
Okay, cool. Okay. Yeah. And you have any questions from this other than this one? Okay, so if no question, then that's all for the second layer of virtualization. So that's where you form your storage pool. Okay. After you form your storage pool, the last thing you need to do will be you forming in your LUN. That's where you create the LUN itself. So when you create the LUN, they no longer will ask you SSD SAS or nearline SAS, because all these have been virtualized into an extent already. So everything is in the storage pool. Okay, everything in the storage pool. So in the LUN, they will ask you, okay, right now in the storage pool, I have 6 plus 2 plus 2. So I have 10 terabyte. So this 10 terabyte, you have basically a lot of extent inside there. Okay, 10 terabyte, a lot of extent. Some of them is SSD, SAS, and nearline SAS. So from the 10 terabyte, how many you need? Okay, how many you need? So let's say that there's 226 over here, 10 terabyte. I just need to create, let's say 2 terabyte of LUN. Okay, so my LUN is equals to 2 terabyte. Okay, so let's see. So I just want to create a LUN, which is equals to 2 terabyte. 2 terabyte. So these 2 terabyte come from where? Come from this 10 terabyte over here. So your storage pool, you will see that your size will be equals to 10 terabyte in the end. Okay, 10 terabyte in the end. Okay, 10 terabyte here. So that's the total size itself. So from 10 terabyte, I take out 2 terabyte. Okay, so this 2 terabyte will be coming in from which disk? Which type of disk? Okay, so you will never know because they will just pick whatever disk that you have. So how do they form the LUN? Okay, so what they do, just now you cut it into an extent already, am I right? So let's say that you have an extent of 4 megabyte. Okay, so every extent is 4 megabyte. So what they will do, they will stack the extent, stack it like this. Basically, they stack it like this. Okay, they'll stack it until you reach this extent size, this whole size, okay, is equals to 2 terabyte. Okay, so they'll stack them together until the whole stack itself, 4 megabyte, 4 megabyte, 4 megabyte, 4 megabyte, 4 megabyte, until you reach 2 terabyte size. Okay, until you reach 2 terabyte size. So that's how they form the LUN for you. Okay, so that's how they form the LUN for you. Okay, so this LUN, you will get a piece from maybe SSD. Let's say that this is SSD. Okay, the first one, SSD. Okay, extend from SSD. This one will be come from SAS. Okay, so let's say that this comes from a nearline SAS. Nearline SAS. LUN itself, when you stack it up into 2 terabyte, you will get different pieces. And this, let's say that this is an SSD. Where this SSD come from, you will see that your chunk group is already virtualized. So you will get a little piece of this number 1. So let's say that, okay, let's say that this part here is from this number 1. This part here is from this number 2. So you get a little bit from every one of these here. So you can see that when you form a LUN, you already 2-layer virtualized and your data will be very distributed among all the hard disks over here. All right. So that's how the RAID 2.0 create the LUN. So this is the final product. After you create the LUN, you mount it to your server. Okay. You mount it to your server. Okay. So that is basically the ending product. So you get 2 terabyte of hard disk. Your hard disk space will come a little bit from SSD, SAS, and nearline SAS. Okay, from the extent itself. So all this extent will be in the storage pool. Okay, so that is basically the RAID 2.0 concept. Okay, so up to here, anyone have any question regarding RAID 2.0? Okay, anyone have any questions?
Yes, sir.
Yeah, let me just capture this one and put it on the WhatsApp group. Okay, yeah. Saya?
For this, so I can say that chunk group size. Sorry, the chunk size is 64 MB.
Correct.
And the extent. What do you call it? The extent size is. We can modify the extent size.
You can modify it, yeah.
From 512 KB to 64 MB.
Yeah, by default it's 4 megabyte.
By default it's 4 megabytes. Yeah, okay.
Yep. Then let's say they use default 4 megabyte. All this size here is 4 megabyte. Then you form a 2 terabyte or 4 megabyte. A lot of them. To form a LUN. Okay. Okay. Any other questions? Okay. So basically, what I explained here is the whole RAID 2.0 concept already. That's the whole thing. Okay. That's the whole thing. Okay. So if no question, then let's see. Okay. Then that's all for the RAID 2.0. Okay, one more thing I never mentioned here will be there's another size, right, for grain. So this is basically, if you use the extent, this LUN is basically we declare as a thick LUN. Okay, we call this as a thick LUN. Okay, so thick LUN is the one that used to form the, use extent to form it. If this is a thin LUN, this extent, you need to further cut it down. Okay, let's say that this is your extent. This is your extent. Okay, so if this is the extent, you need to further cut it down into a grain form. Okay, so you need to cut it down. Okay, into a grain form. Okay, so this is to form the thin LUN. Okay, to form thin LUN. Okay, so you will further cut it down into a grain form. Okay, grain. So what is the grain size? So the grain size is 64 kilobyte. You can't change the size. So every block here is 64 kilobyte, right? It's 64 kilobyte. So you can't change the grain size. So this is to form the thin LUN. Then you further cut it out, get into the smaller pieces. Okay. 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 So let me just capture one more time for a complete one. Okay, so let me just share back to my screen. Okay, so basically that is what I explained, the whole thing over here. You can see the top over here, right? I have just explained. So if you look into my graph, it's better. Okay, you look into my graph, it's understand. You see a chunk group, extend LUN. Okay, so first of all, this domain I mentioned. So you select from physical disk, how many disks you want to put into the disk domain. So in the disk domain, you can create all the physical disk, every disk you have, you put it into one single disk domain, or you can say that I only want to put in the SSD and SAS in this domain number 1. This domain number 2, I put in all the nearline SAS. So you can do that. So when you create a disk domain, they will ask you which disk you want to put in that. You can put in everything, or you can only put in the selected one. Okay, and you can mix and match. You can put in SSD only, or you can say that I want to mix SSD and SAS. So you put in both of them into the disk domain. Okay. So the only thing is that after you put the disk into the disk domain, this disk is considered as a used disk. So you cannot create, again, you cannot, let's say that I use this disk, number 1. Where's my pen? Okay, I'll use this disk, I put it into the disk domain number 1 already. You cannot say that I want to put this disk into this domain number 2. You can't do that. Once this disk is put into this domain number 1, it's already reserved. If you want to use this disk, you have to delete this disk domain to free him back again. Okay, so that is the disk domain. So when you put it into this domain, you have to be very careful. If you don't want to use the disk, don't put it inside there. If you need it, then only you put it. Because once you put it in, you cannot take it out again unless you delete this disk domain, and then you will remove it again. Okay, so this is the disk domain we talk about. So this domain refers to a group of combined disks. It can also be all drive within the system. So this drive capacity are combined with a hot spare space. So that's where you put in your hot spare as well, as I mentioned just now. And then provide as a unified storage resource to the storage pool. So this is the one that you use to construct your next level, your storage pool itself. Okay? Okay, then after that, storage pool. So storage pool basically is created from the disk domain. So this domain cut it into a chunk form, 64 megabyte. Then you form it into a group, you cut it into a smaller pieces to form your storage pool, your extent size itself. Okay? So storage pool is a container for storing storage resource. All the storage space used by the server are provided by the storage pool. Whatever LUN that you want to create to mount to your server will come from here, the storage pool itself. So basically, they separate your storage pool into tier form because you have different type of disks, right? SSD, SAS, and nearline SAS. So they have tier 0, tier 1, and tier 2. So tier 0 is your SSD, high performance tier, we call it. Tier 1, SAS, performance tier. Tier 2, nearline SAS is called capacity tier. So they separate them by different tier because each and every one of these tier, you need to form their own rate policy into it. And then you all form their own rate. Okay? They cannot mix in together. Okay? So the storage tier is integrated of storage media with similar performance within the storage pool. It is used to manage the storage media with different performance and make it easier to provide different storage space based on the performance requirement. So this storage pool here, you can choose, I only want to put in SSD only. You can do that. Or you say that I want to mix it, SSD, SAS, and nearline SAS. Or you don't want to mix it. Okay? So there's a choice for you. You can put in every type, or you can put in one single type. Okay? There's no issue on that one. So that is the storage pool itself. Okay, then in the storage pool, you need to select the rate policy, okay, and the rate type. So this is all the rate type Huawei support. Okay, you have rate 1, rate 10, rate 3, rate 5, rate 50, and rate 6. These are all the rate that Huawei support. And different rate, you can put in different policy. Okay, for rate 1, you can put in 1 disk plus 1 disk because it's mirroring, or you put in 1 disk plus 1 disk plus 1 disk plus 1 disk. Mirror, mirror, mirror. 4 disks to do a mirroring. Okay, so you can do that. In rate 10, you will see that by default, they will choose 2 disks plus 2 disks or 4 disks plus 4 disks. Okay, so this disk is not the physical disk. This disk is basically the disk size it can create. Okay, how many rate disks it will create from here. Okay, then this is the rate 5 policy, rate 3, and rate 5, rate 50. And rate 6. So you need to select each and every one of the storage type, this one, the storage type here, what type of rate you want to run, what is the rate policy you want to run on it. Okay, so you have to select it. So you select different rate policy here that will affect your size, your capacity of your storage itself. Because imagine 2 disks plus 1 P, you divide by 3. 4 disks plus 1 P, you divide by 5. So that means that you have 4 disks will be a storage space, 1 disk is a parity. So your parity size is smaller. Right? Compared with 2 disks plus 1 P, where you have big disks, your parity size will be bigger. So you will see that when you select different type of policy, right, the usable disk, the usable space you have will change. Okay? Will change. Okay, this one I'll show you later when we do the configuration. Okay, then this group is just to group different type of disk only. So you have a SSD SAS and nearline SAS. Okay? So this is just a disk type. Okay, nothing to say about it. Logical drive means your physical hard disk. Disk number 1, number 2, number 3, number 4. Logical disk 1, 2, 3, 4. So that's physical hard disk itself. Okay, we call it LD, logical drive. Okay, then chunk. So chunk, or we call it CK, is referred to fixed size physical storage space that can be divided from the hard drive capacity within the storage pool. So it is a basic unit to form the RAID. Okay? So basically, this is cut from the physical hard disk. So each and every one of your disks is formed from the chunk of multiple disks from the same disk domain, okay? Or we call it this group over here, this domain. Okay? We call it this domain. So chunk is a logical storage unit based on the RAID, and it is the smallest unit for the resource allocation in the storage pool. Okay, so basically that's a chunk itself. So that's how you allocate the resource to your storage pool. Okay, a chunk itself. So after you form the chunk group, you align them, then you cut it. Okay, you cut it to form a extend. So you see that this is basically, let's say that this is a whole chunk itself. The whole color is a chunk. Okay? This whole thing is a chunk. So from a chunk, you cut the extend size. Okay, you cut it out horizontally like this. Okay? So extend is the logical storage space of a fixed size that is formed using the chunk group. You group them together, you cut it to form a extend, okay, as a fundamental unit. So the size of the extend can be changed. So the chunk size you cannot change. 64 megabyte, that's fixed. Extend you can change. So default 4 megabyte. The range is 5112 to 64 megabyte. So 5112 KB to 64 megabyte. So you can only change it one time. Huh? So once the storage pool is created, you change it already, it's created, you no longer can change the extend size anymore. So you can only change it during the storage pool creation. Only one time only you can change it. Once you change, you cannot change it anymore. So the size extend can be changed, and it's the smallest unit for hot data analysis and data migration. So this extend size is also used for hot data analysis to analyze your data as well as to migrate. If you want to perform migration on storage, on SAN LAN itself, it will migrate extend by extend. So basically, it's an extend block by block. That's how they migrate it. Okay, so this is basically the extend size. Okay, then grain. So grain is a smaller unit coming out from the extend. Okay, coming out from the extend. So in the thin LAN mode, the extend is further divided into finer and smaller block. Okay, this block is called as a grain. Okay, we call it as a grain. So thin LAN use grain for space allocation. So the LBA within the grain is continuous, means that you will cut a continuous come from one extend. Okay, that's why it's continuous. So this is the one that you use to form a thin LAN. Extend is used to form a thick LAN. Okay, it's used to form a thick LAN. Grain is used to form a thin LAN. Okay, so that's where you will see the grain coming. If you are just create a normal LAN, a thick LAN, you will just see extend only. Okay, volume and LAN. So volume basically is what storage refer. We refer the LAN that you created, we call it as a volume. Volume number 1, number 2, number 3. So when servers see the volume, you will see as a LAN. So you mount the LAN itself. So basically, volume and LAN are referring to the same thing, right? So volume is internal management object within the storage system. Within the storage, we call it as a volume. So LAN is a storage unit that can be directly mapped to a host for read-write. It's an external representation of volume. So basically, it's the same thing. We just call it differently only. So for server, we call it as a LAN. In storage, we call it as a volume. Okay? That's the only thing different. Okay, so that's all for RAID 2.0 plus. Okay, any question for RAID 2.0 plus?
Yes, hello.
Yes.
Hello, Roy.
Yeah.
Good morning.
Morning.
Please, I want to clarify what you said the other time that
The storage pool is created, you cannot modify it anymore.
okay.
Right?
All right. Thank you.
Yeah, anyone have any questions?
Roy?
Yep, so yeah.
Sorry. What is the requirement of thick and thin LAN?
Pardon? What do you say? I can't listen to you. So yeah?
Exactly. Sorry, sir. The requirement of thick and thin LAN. What is the difference?
Thick and thin LAN.
Yes.
I will explain later. The next slide. Yeah, the next chapter, we will talk about thin LAN. Okay? Yeah, so that will explain later. So right now, you just need to know extend from thick LAN, drain from thin LAN. That's what you need to know right now. Yeah, Bolaji? Bolaji, you have questions? No?
Based on what my colleague asked, Ms. Afe, is asking that the extent that once it is, because she wants to know why we said when the storage, the logic storage, when it's created, that you said it can't be changed. I didn't get that clearly, sir. That you said the size of the extent can't be changed once it has been created.
The extent can only be changed during you create the storage pool. Once the storage pool is created, you can't change it because it's already fixed.
Okay, sir. Then I want to know when it is created, is there going to be any reason why it needs to be modified?
Okay, that is basically a very advanced question. Okay? So who will be the one that decide the extent size? Normally, we storage engineer, we don't decide the extent size. Who will decide the extent size? The application engineer need to tell us what is the extent size. Because when they create the application, they will know what is the data, what is the size of the data they will write into the storage itself. So they will know every block of data is how much. So if let's say that your application, okay, every application block, it require let's say 5 megabyte. So let's say it's 2 megabyte. Every application data block is 2 megabyte.
Okay.
So if you so that means that one extent you need to write twice.
Okay.
You see that? So when you want to read the extent, let's say that you separate it into two. Okay, let's say you separate it into two. So this is 2 megabyte from here. Okay, 2 megabyte. Okay, this is 2 megabyte. Okay, 2 megabyte, 2 megabyte. So you have to write twice, right? One extent. So if let's say that I want to read only this megabyte only, the last one, I just want to read this guy. You cannot skip it because it's a whole extent. So you have to read this one, then only you can reach this one. So your read request will be slower. So if let's say that one block you take half or more the time. So if let's say you want to read 1,000 block, the time will accumulate. Okay. So right now you see the significance. So that's why this extent is not decided by us, not decided by the storage engineer. The application engineer need to tell us. If they don't ever tell us, we just leave it as default 4 megabyte.
Okay.
Okay. So this is basically to optimize the read write.
Okay, read write. Okay, to optimize the read write.
Yeah.
Well, you said for feature essence, you said it cannot be modified. So that means
once it's created, you cannot be modified.
You want to, okay. Once it's created, it cannot be modified. Okay, thank you.
Yeah. So if let's say that you have application engineer come here, I want to have 5112 KB, tell you. So you cannot use this storage pool. You have to create a new storage pool for it. Okay? Because this storage pool, you already decide it to 4 megabyte. You can't change it anymore. Okay? So you have to create a new storage pool, which is a 5112 kilobyte extent. You give it to him.
Kilobyte. Okay.
Yeah.
Okay.
So you have to separate on the storage pool level.
Okay. To optimize the performance, read and write performance.
Yes.
The purpose is to optimize read and write performance. Thank you, sir.
Yeah. Yeah. That is the main. Main reason why you can adjust the extent size. Is to optimize the read write itself. Okay. So this for more advanced people, they will use this one. Right? For common people, general one, you just leave it as default. If let's say that you know the application need how many block size, what is the size every application block you're gonna write the data, then you can modify it. If you don't know, you just leave it as default. Okay? There's nothing wrong on it. Okay, any other questions? Okay, no question. Then we look for the next one. We call it as a host multi-pathing technology. Okay, multi-path technology. Okay, so what's the function of the multipath? To eliminate single point of failure. So imagine you have one single switch. Okay, basically if this switch fails, all your server here cannot access into the storage. So how do you prevent this one? You buy two switch. Then you make it as a multipath. So you have two paths to access into the storage. So any of these switch fail, you still have a secondary path to go to the storage. Okay, so that's basically one of the functions of the multipath. Second function of multipath is to eliminate the confusion on the storage, on the confusion of the storage. So what am I talking about? Confusion of the storage. So let's say that at the storage, I create one LAN. Okay, this LAN I create on the storage. Okay, then your storage, when your storage, this LAN, you want to mount to the server, how many paths you can go out from the storage? That is basically how many controller you have, the storage controller you have. So in Huawei, by default, you will have two controllers. Am I right? You have two controllers. So that means that this LAN, if you want to go to the server, you have two paths to go out. Okay, you have two controllers to go out. So basically, controller 1 go out, controller 2 can go out. Okay, but when server C, you do not know, he is not intelligent enough to know that these two controllers basically pointing to the same LAN. He's not intelligent enough. He thought each controller, each target give you a different LAN. But in the fact, you only present one LAN to him. He will see two LAN because he has two paths to go into the storage itself. So that is the confusion on the server side because it's not intelligent to know there is a multi-path running on the storage itself. So what you need to do, you need to install a middleware. Okay, you need to install a software or middleware on the server. So the multipath, basically you need to install the multipath software. So what's the multipath software to? Okay, the multipath software first will see these two targets, is it coming in from the same source? So if yes, then you will see he will create a multipath driver. You create a multipath driver. So your server, when you want to go to this storage, you point to the multipath driver, where you only have one driver. So that means that you only have one path to go to the storage pool. Then the driver will be the one that decide you are going out from the controller number 1 or going out from controller number 2. The driver will decide. So he's intelligent enough to know that these two is coming in from the same devices. So I will make one virtualization layer to point to your server, so your server only will see a single path. In actual fact, there's two paths below it. So the multipath driver will be decide you are going in from controller A or going in from controller B. Okay, so you will decide. Okay, then after that, this LAN, okay, host A here, he will present one LAN to you. Am I right? So you present one LAN to the server. Host B will also present another LAN. Okay, so basically you will see there's two LAN over here. Okay, LAN and LAN, right, over here. So, but basically this LAN is coming in from here, one LAN only. But because you have two paths, you point to the multipath driver will see there's two LAN. But he know that these two is actually the same thing. So what he will do, he will create a disk driver and a virtual disk. So basically he will virtualize these two LAN together to form a virtual disk on top here. Okay, so this is basically your VLAN. Okay, virtual LAN. Then your server will only see one. So this is right now is correct already. One LAN to one LAN. So your server will mount this LAN itself. Okay, this LAN come from where? This LAN come from two paths. So the multipath driver will decide you go out from path 1 or path 2 to reach to this LAN over here. Okay, so this is the second function of the multipath itself. Okay, first is to eliminate single path failure. Second is to reduce this type of confusion that happening on the server side. Okay. Okay, integration method of multipath software in OS. So in Windows, Linux, or Solaris kind of platform, this kind of platform, the layer where UltraPath drive live is shown as below. So basically your UltraPath is located, okay, below your virtual disk, on top on your SCSI connection. Your SCSI initiation and target connection is on top of the target connection itself, but it's below of your disk. That's where your multipath is located. So it's located in the middle. So sometimes we call it as a middleware. Okay, we call it as a middleware. Okay. Okay, so this is where the multipath form. Okay, so next we look into this one. We call it as an ultra path. Okay, so ultra path is just a Huawei software. Okay, Huawei have their own multi-path software. Okay, Huawei multi-path software. So Huawei multi-path software, basically the name is called ultra path. That is the name for it. Basically, it's do multi-path. So if you don't want to use Huawei multi-path software, okay, you don't want to use Huawei multi-path software. Okay, so what other type of multi-path software you can use? Okay, you can use the native multi-path, we call it. Okay, native multi-path. Okay, native multi-path. Okay, so what do we mean by native multi-path? So basically, it will be from the OS. So each and every one of your OS, they have their own multi-path software pre-installed already into the OS system. So if you don't want to use the Huawei multi-path software, we call it ultra path, you can use the OS native multi-path itself. So Windows have their own multi-path. Linux have their own multi-path. Okay, so all the OS have their own multi-path software. So this is what we call as a native multi-path software. Okay, not multiple. Let's start code it. Sky multi-path. Okay, native multi-path. So basically, it's from your operating system. Okay, so this is called the native multi-path, or you can use Huawei multi-path. We call it as a ultra path. Okay, so it's the same thing. Okay, they do the same thing, just that different vendor coming out from it. Okay. Okay, so how does the multi-path do? So first of all, you can do the failover. So if you still remember here, you have a multi-path driver, am I right? So this driver will be pointing into two different controllers. So let's say that this is your controller A. Okay, CTRA. Okay, this is your controller B. So you have two paths. Okay, so you have two paths on the controller. So the ultra path will be the one that decides who is a primary, who is a secondary. Okay, so he will be doing the deciding. So by default, let's say that path 1 is your primary. So whatever application you want to access into the storage, you will go through path number 1 to go to the storage itself. So let's say that this is a primary. But let's say that suddenly the primary path to the storage here failed, okay, or your controller failed here. So when ultra path send the signal, he do not receive any reply. So if we do not receive any reply, so if this say ultra path will say that, okay, this guy is failed. Okay? Or the controller A tell the ultra path, hey, I failed to access into the storage. I reply to him. I failed to access the storage. Then ultra path will do the failover automatically. So I know that, okay, I cannot reach the storage through path number 1. I will switch to path number 2. Automatically failover. Okay? Then switch number 2 can access into the storage. Reply to the ultra path will tell application, okay, use path number 2 to access into the storage system. Okay, so this is how the ultra path failover mode work. Okay, so all these are automated. So you will do the automatic failover. Then, so this for failover. Okay, then ultra path also support failback. So what do you mean by failback? So after you fail over from primary to secondary, if your primary come back up, okay, come back again, you have to fail back the secondary back to the primary. So this is what we call as a failback. Okay, ultra path feature. So you can fail back into the ultra path. So the ultra path will retransmit the I/O back to the normal route after detect that the normal path have recovered. So how does it fail back? There are two methods to do the path recovery. Okay, first is for system that support hot plugging technology. For example, Windows. So hot plug technology means that when you connect to it, you automatically detect. When you disconnect, you will automatically disconnect from your system. So this is what we call as a hot plugging system. Okay. So in hot plugging system like Windows, when there's a path failure, he will automatically disconnect from the path. So he will know this path is failed. When your path recover, you will automatically reconnect back to the system. Then the system will know that, oh, this path is recovered. So the broken path between the host and the storage will cause the SCSI device to be removed or disconnected in this case. So when the link is recovered, you will trigger the automatic connection. Okay, you will reconnect back to your device. Then the ultra path will know this path is recovered. Then it will immediately fail back to the recover path. Okay, so this is for system that support hot plug technology. Okay. Second is for system that does not support hot plug technology. For example, AIX. Okay, AIX that do not support hot plugging, or earlier version Linux that do not support hot plugging. So when you do not support hot plugging, means that I cannot detect that your system is disconnect or connect through the system. So how do I know? They need to send something for periodic interval cycle to do a health check into it. So that means that ultra path will check the path in configure specific time of interval of time to see the path recover or not. So once you recover back, you need to wait for the next health check. Then only the ultra path will know your system is recovered or not. So there is something like a heartbeat, okay, to detect this path is up or down or not. For systems that support hot plugging, they do not need heartbeat because once you connect, you're connected. Once you disconnect, it's disconnected. So he will know immediately. Okay, so this is the ultra path failback feature. Okay, so that's all for the multipath. Okay, multipath itself. So anyone have any question regarding multipathing?
Hello, Roy.
Yeah, Tonga?
Yeah, I have missed most of that multipathing. I got disconnected. Can you do just a rough overview so that I can just jot down a few things?
Okay, so our multipath, actually there's two main functions to prevent
Hello, I know you all have questions, but please allow the lecture to complete so that just document your questions for me. When we are done with the presentation, then I will take your questions. Thank you. So everyone is completely muted. Thank you.
single point of failure, okay, like this, single switch. Right now I have two switch, or to prevent the confusion on the storage itself. So if you do not have the multipath, when you have two controller, the two controller will tell the server each controller have one LAN, but in actual fact you only have one LAN. So to prevent this thing, you can also install multipath software to virtualize these two things into one driver, so that your server will see one path. Then the multipath will decide who will be the primary, who will be the secondary. So this, you let the multipath to do that. So your server only will see a single path. Okay, that is the main function of the multipath. So multipath, okay, they support failover. Ultrapath is just a name for Huawei made multipath software. What we call the name for multipath in, sorry, okay, so in multipath they support failover, automatic failover. If you have system that does not support hot plugging. For system support hot plugging, when you connect, it will detect. When you disconnect, it will detect automatically. So this kind of thing is very fast. Once you reconnect back to the system, I will automatically fail back into it. For system that does not support hot plugging, for example, AIX type of OS, they don't support hot plugging. So in this case, how do I detect your path is come back or recover or not? You need to use, they need to have some heartbeat to check that. Okay, so basically that is a summary for the whole multipath. Okay, Gitonga?
Yes. Thank you.
Yeah, Bolaji?
Thank you, Roy. Please, the middleware in the layer part, please can we go there and just do a few years this place, a little recap again. There's a point you mentioned, I want to get it very clearly. Talking about the multi-part, you said it's below the digs and why is this a sound that is this? I want to know, is it the standard?
Yeah, this is standard.
Okay, it's called middleware, right?
We have a name for it. We call it middleware.
Okay. Thank you very much, sir. I appreciate it. Yeah.
Okay, anyone have any questions for multipath before we move to the last one? Okay, so if not, then we look into the last content over here, this reliability technology. So how do we measure or how do we know the disk reliability technology? So all the disk reliability technology in the mechanical hard drive is basically come from the component itself. So how well your component can cope. So that's why your reliability is equals to mechanical part plus electrical part plus the software, the coding they put into the hard disk. That's basically equal to your disk reliability, right? Okay, so your hard disk, your mechanical hard disk, you will see there's a lot of time that your hard disk will fail. So what is the main cause? Okay, what is the main reason? Okay, or the most people will face when the hard disk failure? So what caused hard disk failure? Okay, type of disk failure here. So top number one is uncorrectable. So uncorrectable basically is called back sector. So your hard disk have a lot of back sector, you cannot access it anymore. So this is basically the top one type of reason or top one type of failure that always happen, okay, in the hard disk, okay, back sector. Top two kind of failure is that when you send back to the factory, then they say no problem found, okay. That's around 12% of the disk error found no problem after you perform a ROF, return to factory for analysis. Okay. And then top three, this will predict failure before it happens, but the failure detection rate is just 76.9%. So most of the failure are unable to detect in advance. So this type of failure, we are talking about mechanical part failure. Your actuator fail, your read-write arm fail, all these things over here. So your disk actually, they will do some diagnose for you. But the problem is the diagnose rate is just 7.69%. So most of the time when your disk fail, the mechanical part fail, you are unable to detect. Okay, so this is basically the top three kind of reason, okay, why you have this failure. So this is just to tell you the type of this failure you will encounter, okay, when you go into the storage system. Okay, so how do we increase, okay, the reliability, okay, or to improve your disk itself, to improve, to know that when you're going to fail? Okay, how do we do that? So there's a lot of way, okay, to do that. Okay, one way is what we call as a disk smart scan and back sector recovery. So Huawei system, they come with a disk smart scan by default. So you put your hard disk into the storage system, then they will do the background scanning for you. Okay, this smart scan. And if they detect any of your disk that is a back sector, he will try to perform the recovery for you. Okay, you try to perform the recovery for you. Okay, so this is basically one of the Huawei features in the storage system. So they do come with a disk smart scan and back sector recovery. Okay, so this is basically no need to activate it. By default, you purchase a device, you put in your hard disk, then they'll run a disk smart scan in the background. Okay, in the background. Okay, so this is one way to do that. Okay, second, Huawei also has something called the Smart Online Disk Diagnostic System. So this diagnostic system, basically you need to install a software, okay, we call it a toolkit or smart kit over here. So this software, what you will do, when you install it, you can connect it to your storage, then you perform a online disk diagnostic. Online means that your device is running, so you can perform an online diagnostic itself. So in the online diagnostic, what he will do, basically he will monitor your disk itself. Okay, you monitor all your disk performance. You will monitor all your disk itself. Okay, any symptoms or not that show that your disk is going to fail. Okay, so they will perform a monitoring. This drive will periodically analyze minor disk error and predict abnormality in the disk head or the disk plater. Okay. Okay, this will be the monitoring part. So after you monitor, if they detect there's a disk that some failure happening, then you will quarantine the disk. So when a single abnormal occur, you will quarantine, then you will run the diagnostic on it, analyze and do some recover action if you're able to do it. So when multiple abnormal occur, it will quarantine the whole disk from further usage. So you cannot use the whole disk anymore. If they detect there's more than one type of failure that they detect is going to happen, okay, they will quarantine the whole disk. So after they quarantine, they'll run the diagnosis for you. So what they will do, they perform the power on off self test on your hard disk. They perform a smart test. They perform an I/O read write test, head test, verify, and this self-check operation, all these things they will do it, right? And analyze this faulty reason and degree of this failure. So they will give you a summary out. This, how many percentage is a wear and tear? Okay? How many percentage left? The lifespan is up. Okay? So done all these diagnose for you. Okay, so when they diagnose, there's some bad sector. Let's say that I diagnose there's something bad sector, or there's some read-write failure or stuck over there. He will perform a simple recovery for you. So in the recovery, basically you only have two outcomes: either successful recover or fail to recover. So if successful recover, then he will release this out from the quarantine. Okay, join back into this domain, perform your read-write again. If your disk fail to recover after I diagnose all the problem, I fail to recover some of the problem, then this disk will mark as failed. Basically, they tell you this disk is failed already. Then he will reinitiate the RAID reconstruction because you mark this disk as failed disk. Whatever data in the failed disk, I need to do the reconstruction again. Okay? Yeah, Augustine? Okay? So this is the smart online disk diagnostic system. So if you want to use this function on Huawei storage, you need to install a software. We call it as a toolkit or smart kit. Okay? Toolkit is the old name, smart kit is a new name. So you need to have a software application to run this one. Yes, Bolaji.
Yeah, I know this is going to be a very rare case, but an event where we had mechanical failure, disk mechanical failure, smart online disk diagnosis system can it in a way detect and fix it? So
he will detect, he will try to fix it, but not 100% guarantee. If he cannot fix it, he will mark this as failed.
Okay, and smart online disk diagnosis system comes with the storage server, right? Or we have
No. Your storage server is your storage server. Smart online disk diagnosis system is one of the software. You have to install application. Then after that, use the application to run the diagnostic on the storage itself. So you still need to buy the storage. They don't come with a pair. They don't come with a set. This is actually just an application, a software only to run the diagnostic. Okay?
Sorry, hello?
Yeah.
Hello, sir.
Yeah.
Sorry. Sir, how can we get this smart online disk? Is it a Huawei product or?
Yeah, it's smart kit. Then you will see inside the smart kit, you can install another function. We call it as an online disk diagnostics. So you use this system to run the online diagnostics on it. So you need to download this application first, smart kit. Okay?
All right. Thank you. Thank you very much, sir. I appreciate it.
Yeah. Okay. Okay, next is called disk pre-copy. Okay, disk pre-copy. So this function, this pre-copy, you no need to configure it one because the system will automatically activate this system. Okay, when you construct a RAID. Okay, when you construct a RAID. So how does this pre-copy work? So let's say that right now I have 1, 2, 3, 4, 5 disks. Each and every one of these disks, you have a hot spare space inside. Okay, so in the normal status, the disk status are monitored in real time. Then he detects when a certain hard disk symptom of failure. So they detect, let's say that the first hard disk here, they show symptoms of failure already, but not yet failed. Just a symptom only, it's going to fail. So what you will do, the RAID basically will perform a RAID pre-copy all the data out from this one into another disk. So that when this disk fail, you no need to do the reconstruction on the spot. So basically, I pre-copy out first the data to the hot spare space. Then until this disk fail, I will declare this is as failure. Okay? Then I will not use this disk anymore after I pre-copy out. So this is basically the disk pre-copy function. So when a certain hard disk shows symptom of failure, move or migrate all the data within this disk to the hot spare space, to all the other disks. Okay? So this is what we call as a disk pre-copy. Okay? So this feature is activated when you are in the when you activate a RAID function to your storage system. Okay? This will automatically include already. Okay? Okay, then another one is called fast response to slow I/O. Okay, so how does this thing work? So let's say that you have 4 hard disks over here. Okay, each and every one of these hard disks store different type of data. So let's say that this is a LUN here. Okay, there's a LUN here. Okay, there's a LUN here, store data A, B, and C, D. And this LUN come from where? Come from a RAID. Come from this 4 disks over here. So let's say that you distribute the data. Okay, storage 1, you store data A. Storage B, you store data B. Storage C, you store data C. Storage D, okay, storage number 4, you store data 4. So there's a 4 data here coming in from this 4 disks because it's running on the RAID. Okay, then when this server, he want to read A data over here. Okay, you want to read A data over here. But when he requests for A data, there's very, very long time. Okay, the latency is very long. He still haven't replied to the server. So the server said, hey, LUN, please send me data A. But LUN here need to get data from storage number 1. But storage number 1 never reply you. Okay, never reply you. Maybe there's something wrong on here. And they never reply you. So he will only wait for a certain period of time. After they pass this certain period of time, there's still no response. Then I will ignore response from storage A, the storage number 1. Then I will perform a reconstruction immediately because you're running on the RAID, right? So I get B, C, and D data. I want to get A data over here. So I will reconstruct using the RAID reconstruction to get back the A data and respond to the server first. Okay? Because server need the request, need the answer. I will respond to server first. After you respond to server, then only you come back and check, hey, storage 1, what's your issue? Why so long you still haven't replied me with the data number A? So he will do the diagnostic on this guy. Okay, so this is what we call as a fast response to slow I/O. So when your response is too slow, other storage basically will just do the reconstruction to reply to the server first. Because reply is important. The server need to get the response first. So once you reply, then you do the diagnostic. What happened? Okay, to the storage system. Okay, so this is another method to do that. So basically, that's all for the method to do the to improve your storage reliability. Okay, storage reliability. Okay, next we look into the RAID overview of RAID reconstruction technology. So in here, we need to compare between traditional RAID and RAID 2.0. Okay, so in traditional RAID, you need to manually configure independent disks to form as a hotspot. Okay, so you need to configure a global or local hotspot disk. Okay, for this one. So you need to plan it yourself. But in RAID 2.0, your hotspot will be distributed, so no need to manually select which disk to become a hotspot. Okay, so there's a difference between traditional RAID and RAID 2.0. Okay, then after that, we look into the reconstruction. Okay, we look into the reconstruction. So in traditional RAID, your reconstruction many to one. Yeah, Richard, do you have any questions? Okay. Okay, doesn't matter. Let me continue. Okay, so in RAID, traditional RAID, you are constructing many data into one hard disk. Okay, that's why we call it as a many to one. So when you let's say that you imagine this data here is 1 terabyte. Every 1 terabyte you're going to reconstruct into one single hard disk. So you only have one single hard disk to reconstruct all the 1 terabyte data. So the reconstruction time will be longer. Okay, will be longer. So this is basically the traditional RAID reconstruction. Okay, because you have physical disk as a hotspot. So whatever data here, reconstruction. In RAID 2.0, since that your hotspot is distributed, when you perform reconstruction, basically you will split the job into all the hard disks. So basically every one of the hard disks will do part of the reconstruction. So in compare one hard disk to do the reconstruction, right now I have 4 hard disks to do the reconstruction. So I have faster speed. And all the reconstruction will be happen parallelly, okay, between all the hard disks. Okay? So that's the difference between traditional RAID and RAID 2.0 reconstruction. Okay, lastly, traditional RAID hotspot exists and longer reconstruction time because all of the data here you need to reconstruct on one single disk. So that's basically taking longer time because they need to reconstruct one by one. Whereas in RAID 2.0, your reconstruction will be balanced among all the disks and your reconstruction time will be shorter because each and every one of the disks, you just do part of the job. Okay, you do 20%, I do 20%, then you do 20%. So everyone do a little bit. So your reconstruction time will be faster because they will reconstruct concurrently, okay, at the same time. Okay, so this one will be the rate reconstruction technology. Okay, so in here basically is to show you even a clearer example between the traditional rate reconstruction to rate 2.0 reconstruction. So you can see that if hard disk one fail, in here, hard disk one fail, whatever data in the hard disk one, you have to reconstruct everything into hard disk 5. So this is a lot of data to be reconstructed into one single hard disk. So this is basically how the traditional rate do the reconstruction. In rate 2.0, since that your hot spec is distributed, okay, is distributed. Okay, let's say that yes, here, hard disk number 4 and number 9. So when your hard disk one fail, he only will reconstruct these two data, 12 and 13. So he will see, hey, where is your hot spec? So there's one hot spec in hard disk number 4, one hot spec in hard disk number 19. So the 12, I reconstruct in hard disk number 9, and number 13, I reconstruct in hard disk number 4. So you see that? Both of these hard disks will do the reconstruction at the same time. So if let's say that this guy, okay, reconstruct the same data, it's going to take double the time compared with this guy, okay, rate 2.0. Okay, so that's basically how the reconstruction is faster. So this is what it requires a many-to-many reconstruction. Many data reconstruct on many hard disks at the same time. Okay, so basically that is your rate 2.0 plus. Okay, one thing you have to be careful about rate 2.0 plus that I never mentioned here. Okay, what happens if let's say that this hard disk one fail, I already use up, okay, this space and this space. I already use up this space and this space. Will the system generate a new hot spare space or not? Okay, he never mentioned here. If I use up these two hot spare space, will the system generate a new hot spare space? The answer is no. Okay, it will not generate a new hot spare space, okay, until you replace this hard disk. Until you replace hard disk number 1. So in this case, you need to immediately replace. If there's any disk failure, immediately replace. Because once the hot spare space is used, I will not create a new hot spare space until you replace this hard disk. Okay, the hard disk number 1. Okay, that is how the rate 2.0 do the regeneration of hot spare space after you use it. Okay, so you still need to replace this hard disk after the hot spare space use. Okay, and if not, then he will not recreate a new space for you, new hot spare space. So if there's no new hot spare space, if there's anything happening on your data, he will not do reconstruction until he get a new hot spare space. Yes, sir. Okay. So basically, this one will be all for the rate 2.0 plus. Okay. Anyone have any question regarding this chapter? Okay. Anyone have any questions? Okay, so if no question, then we look into here. Okay, true or false? Is rate 5 higher than rate 0? Okay, so the answer is false. Okay, there's no such thing as rate 5 better than rate 0 or rate 0 better than rate 5. They are running a different mechanism. Okay, their rate mechanism is different, so we cannot compare both two. So there's no such thing as one thing higher than another. Okay. Okay, which of the following are common rate type? Okay, so the answer will be all of these 3, okay, except rate number 4. So rate 10, rate 5, and rate 0. Okay, so the answer is A, B, C, not rate number 4. So rate number 4 is not common. Yes, Bolaji. Yes, Bolaji? You have questions? You are still mute, Bolaji.
Okay, yeah. Yes, hello, can you hear me?
Yeah, I can hear you.
So I'm so delighted by this quiz right now. I was about this quiz. I was going to say true. He said it's rate 5. I was going to say true, but I was trying to do some accounts because in have more research than grade 0. I don't know, in the place of the higher level, talking about things, I think grade 5 is more higher in terms of reading.